we get this picture, which is example 3.6 on page 41. And it says, determine the resultant of the parallel force system in figure 316 acting on the horizontal beam AB. All forces are vertical. Neglect the weight of the beam. And we'll pretty much not even have to worry about that from now on. We'll neglect the weight of the beam, at least for now. Now eventually that can play a part, can't it? If you've got a beam that's, in this case, how long is it? 11, 13. That's interesting. Do we know? I'm pretty sure we need a distance for B there. Well, if we're just doing a moment, we don't. But if we're trying to figure out what's going on at A and B, we've got to have another distance there. You've got to know the distance from A to B to be able to figure out what the reactions are at A and B. Now we can do a moment. I got ahead of myself, because all he wants to know is what's the moment that will tell me that reaction force based on those four forces. Okay, so he's not doing let's find out what's going on at A and B here. He's just figuring out what's my one force that takes the place of all four of those. And you can solve that based on this. So let's see, is he doing, yeah, he's doing a moment at A. Well, he's finding out the resultant value, and you're just summing up those forces, right? So we've got negative 25 minus, better get that hashtag right, 15 plus 10, right? Minus 20. That ought to equal negative 50, which is 50 pounds down, right? Because that could turn out to be a positive number, which then screws up my reactions at A and B if I had assumed that they were up. But that's all right. Even if you assume that they're going one way, the way we do this, it will tell you that you were wrong. What it will do is it'll tell you it's a negative value, and then you know you were wrong, and you have to assume the other direction. You don't have to assume, then you know. Okay, so when that's why I said assume that O in the X was going to the right. If you make that assumption and it's wrong, it will tell you that you were wrong. So then you make a design change, right? It's not, you weren't wrong, you just make a design change. Remember that. Mechanicals don't make mistakes. Make design changes. It's just the way it is.
In this case, upward force is positive and downward force is negative.
Say again?
In this case, the upward force is positive, downward force is negative.
That's correct. Just like when we were doing our sum the forces in the X and sum the forces in the Y. Yeah. Whatever's going on there in that picture, if it's going down, it's negative. Just for the resultant force. This is just for what's that doing in the X or Y direction. Okay? This doesn't have anything to do with the moment calculation. This is just saying, if I've got this force R that's located right here somewhere, if I've got that force R, is it going up or down? And if it's going down, it's a negative. If it's going up, it's a positive. So any of these, and even if for some reason I had a force that was going like this, I can get the arrow going on there. If I have a force like that, and we will, then all that does is we're going to break that out into, well, actually, that's in the wrong spot. Okay, that's going to end up being this. It's going to go here, and it'd go there, wouldn't it? That's all we're saying. So then we would have a force that would be going down, so that would be negative. This one, we wouldn't really care. It's not. It would be negative, but you wouldn't add that in here. Okay, so it won't. It's not going to make a difference at that point. But we don't have that now, so we'll get that out of there. Okay. So now he's doing some the magnitude at A, right? Yeah. And you need to label where you're taking that moment from. So he's doing some the force or the magnitude at A. So
The moments or something?
moments, yeah, thank you. Moments, not magnitude. We just did the magnitude, didn't we? That was the R. Okay. All right. So then the 25. What about it? Goes away, doesn't it? Because the distance is 0. So it can't make it spin. Now we're talking, when we talk about moments, not magnitude, thank you. When we talk about moments, it's what's it going to do as far as how it spins. Okay? So that one turns out to be 0, so we forget about it. Then we've got the 15 pounds that's making something happen. And that's a negative value, right? Because it's making it go clockwise. And it's 3 feet. Well, then we've got plus 10 pounds because it's making it go counterclockwise, right? Again, this is one where, excuse me, we don't want to think up or down when we talk about moments. We're looking at how it's spinning. That seems to be one that people kind of forget when they're taking a quiz. So moments is all about the spin. And that value is 6, right? It's 9. I wrote it down right. I just said it wrong on purpose.
On purpose.
I did. Remember, if I tell you I did it on purpose, I did it on purpose. I wrote it down before I even said it.
I thought maybe you were making a design change.
No, well, yeah. No, when I screw up, I'll tell you I screwed up, just like when I said magnitude, and I should have said moment. So I thought I told you guys that. If I say I screw up on purpose, I did. Because otherwise, you'll know. I'm not going to insult your intelligence. You will know if I screw up. Okay? So I'm not going to try to BS my way through on that. No. I'm not very good at that. That's why we have no secrets at home. Or at least I don't. My wife might, but as long as I don't know, I'm good. You know? And then we got the 10 pounds, and it's 9 feet, right? It's just 3 plus the 6. Okay? Then we've got 20 pounds. It's making that thing go clockwise, isn't it? Which is negative. So negative 20 pounds times 11, 14 feet. Correct? So let's see. Let's keep this consistent. So we'll move down here a little bit. That value then is, punch that all in. Hopefully it'll come out to 235 pounds feet. And everybody always says foot pounds, don't they? But in all the books and all the engineering stuff, it's pounds feet. I don't know where foot pounds came from. I don't know why people decided, somebody decided that was better. I don't know.
The distance is feet and
Do what?
the distance is in feet.
Yeah, well, I know where that came from, but I mean, as far as reversing the way they said it, yeah, it comes from, we've got pounds on the force, right, and feet here, So yeah, that's where that comes from. But for some reason, people most of the time, like mechanics out in the field, and I think even, well, if you look on the specs on, let's say, an impact wrench, it's so many foot-pounds, but yet we're dealing with pounds, feet.
The multiplication, so we can interchange anyway.
Do what?
The multiplication, we can put left and right.
Oh yeah, it can go either way. I don't know what genius decided it should be the opposite of the way the books say it. You know, that's all I'm saying. Yeah, it means the same thing. Now, but what do we have? So that came out a negative value, didn't it? Which means that it was clockwise, right? CW and CCW is probably the best way to do that. Because the problem with that, if you don't do it with the letters, some people get a little sloppy and they go like that. And then I look at that and it looks like a Y value, or like a negative down, doesn't it? As opposed to clockwise or counterclockwise. So if we don't have a picture on this one, we're better off. Because somebody would swear up and down that that's got an arc to it. Well, if we do CW and CCW, there won't be any question on a quiz. And I don't like that to be ambiguous. Throw a big word in there since we're recording this.
I have a question.
Okay.
So, if we, like in this example, we don't have any, but if we had forces on the other side of the A, then our forces going up would be clockwise and our forces going down would be counterclockwise.
Yep.
So it would be reversed.
Yep. And there will be problems like that. Yeah, you might have a cantilevered beam out there. You know, it might be cantilevered out, so it's beyond that point. And yeah, you can have forces like that. So yeah, and we'll treat them just like you said. If it's going up, if you will, it's going to make that thing spin clockwise, which would be negative, right? So up in that case is a negative.
So we have to pay attention to the direction of it.
Absolutely. In everything we do from now on, whether it's sum the forces in the X or Y, or do a moment equation, you always have to pay attention. Yep. Oh, I love it. This is fun stuff. We still got some time. So then there's another situation here. Now that was where we had, those are all concentrated. Go ahead, Clark.
So what's the point of that dotted R and that X value underneath? What?
If you took all of these forces, these four forces, and add them up, then your resultant force, the one that would take the place, if you will, of all of those forces, would be this one right here that is 50 pounds, and it's, oh, let's see, we gotta have that X value. I skipped that, I guess, because we've got to find what that X is. Sorry about that. We've got to figure out what the X value is. Okay, so the X value is, and basically, well, you're going to write X, in this case they say X bar, and I think that's how it's labeled here, isn't it? Yeah, X bar equals the summation of the moments at A divided by the resultant magnitude, okay, which is 235 pounds-feet, right, divided by what, 50? Yeah, pounds. The pounds cancel out, right? So your answer turns out to be 4.7 feet because the pounds cancel out. Thank you. Glad you asked. So I just flat out, I was moving on. So now what that tells me is, now we've figured out with all four of those forces what they're doing to that beam, we could say that we've got one force here that is 50 pounds and the distance is 4.7 feet away from A. It has to be relative to A because that's where we took the moment. Okay? So wherever you take that moment from, that's where you have to come from with your distance. That is key as far as that goes. Now, that's a concentrated. Oh, go ahead, Brian.
So this is probably oversimplification, but if we were calculating the force on the beam, we would keep that initial 25-pound force and take away.
Well, yeah, we're not. That's just showing you can figure out where one force would be acting on that beam. Okay, we're not going to do all of our problems like that. We're going to use all those problems, all those different forces and where they're located, and then what we're going to do. That's what I was telling you. And I've been trying to get into that next step too fast, actually. If we know the distance between A and B, let's go up here a little bit more. If we know this distance, come on, there it is. This distance from here over to there, that's going to be. If we know that distance, we can solve then for what's going on at A in the X and Y and what's going on at B in the Y in this case. Okay, but without that number we can't do it. Okay, and we're not going to go and find this resultant here. We're just going to use all these forces just like they are. Okay, and we'll do a sum of the moments at A, and it'll tell me what B is because that'll be the only unknown. Or we could do the moment at B to find out what A is, because then it would be the unknown. In fact, you can use that to check your work. You can do a moment at A to find out what B is, then you go back and plug that force back in at A and find out what A is. Well, then you could do a moment at B, and that would tell you what A, and those two A's better match up. Or you're not static, are you? And you're wrong. So, God, I hate that word. Okay? So yeah, that's what we were doing with that particular problem.